Imagine yourself walking through Central Asia about 34 million years ago. The world as we know it today was in a full remodeling phase. The dinosaurs had long since left the stage, and Earth was passing through the Oligocene, a transitional period where the climate began to cool and dense tropical forests gave way to more open woodlands. It is in this landscape of renewal that a true titan emerges, the Paraceratherium. Often it is simplistically described as a rhino relative, but that comparison doesn't do justice to its magnitude. Paraceratherium was the pinnacle of giantism among land mammals. If we could place it next to a modern African elephant, the largest land animal today, the elephant would look like a calf. This giant reached about 5 to 6 meters in height at the shoulder and weighed an impressive 15 to 20 tons. To visualize this scale, imagine the weight of 3 adult elephants concentrated into a single organism. It did not possess the characteristic horns of its modern relatives. Instead, its evolution bet everything on raw size and vertical reach. It was the legitimate heir to the niche left by the great herbivores of the past, proving that nature, even after the age of giant reptiles, still had the recipe for creating colossi that made the ground shake with every step.
Keeping a body of this size functioning on dry land is a nightmare of biological engineering. The first major challenge is gravity, how you carry oxygen-rich blood to a brain positioned several meters high, far above the level of the heart. Physics tells us that to overcome this pressure column, Paraceratherium needed a cardiovascular system unparalleled among mammals. Although the hearts of these giants were not preserved, mathematical models and comparisons with modern giraffes indicate they possessed a massive heart with extremely thick muscular walls. Its blood pressure had to be incredibly high, nearly double ours, to ensure blood flow was not interrupted. Additionally, it likely relied on a system of special valves in the neck veins to prevent blood from rushing down too forcefully when it lowered its head to drink, which could cause a fatal brain hemorrhage. The anatomy of its face also reveals a fascinating specialization. Marks on the skull bones suggest it possessed an extremely mobile and prehensile upper lip, almost like a short trunk or the lip of a tapir. This structure, working in conjunction with its long neck, allowed it to perform selective pruning at the tops of trees, reaching branches and shoots that no other herbivore of the time could touch. It wasn't just large, it was a precision machine designed to dominate the heights of the forest.
Paraceratherium did not live in an empty world. It shared the plains and woodlands of ancient Asia in regions that now comprise Pakistan, China, and Mongolia, with a diverse and dangerous fauna. However, its hierarchy was clear. It was the battle tank of its era. Due to its colossal size, a healthy adult had no natural predators. No carnivore of the time, no matter how hungry, would risk a direct confrontation with an animal that could crush it with a simple movement of its leg. But that doesn't mean the environment was peaceful. The giant coexisted with formidable predators like the hyaenodons, carnivorous mammals the size of polar bears with jaws designed for crushing bone, and the nimravids, known as false saber-toothed cats. These elite predators likely patrolled the shadows, waiting for a rare opportunity, a calf that wandered away from its mother's protection. The existence of Paraceratherium shaped the ecosystem. By moving through forests and toppling smaller trees to feed, it created clearings, allowing sunlight to reach the ground and promote the growth of low-lying vegetation. It acted as a true environmental engineer, creating opportunities for smaller species to thrive. In a world of sharp teeth and crushing jaws, the Paraceratherium's best defense was simply being too big to be ignored.
When Paraceratherium was so dominant and virtually invulnerable, why did it disappear? The answer lies in the fragility that giantism itself imposes. Being the largest of all is an incredible competitive advantage until the world's rules change too fast.
Around 23 million years ago, the planet underwent severe climate changes. The retreat of ancient seas and the uplifting of great mountain ranges like the Himalayas altered rainfall patterns in Asia. The humid forests and woodlands the giant depended on began to dry out and were replaced by grasslands. For an animal that needed to consume hundreds of kilograms of tree leaves every day, this change in available diet was fatal. Furthermore, giantism carries a very high reproductive cost. It is estimated that the gestation of a single calf lasted about 2 years, and this young one took nearly 2 decades to reach maturity. With such a slow life cycle, the population could not recover from losses caused by food scarcity or prolonged periods of drought. New competitors also emerged, the ancestors of modern elephants, which possessed more versatile digestive systems and could better handle low-lying vegetation. Paraceratherium was, ultimately, a victim of its own perfection. It was designed for a world that ceased to exist. Its extinction marks the close of a chapter where mammals tested the absolute limits of physics in biology on land. And you, had you ever stopped to think that long before us, Earth was dominated by giant rhinos that made elephants look small? Which of these adaptations did you find most impressive, the superpowered heart or the tree pruning lip? Leave your opinion in the comments. Let's talk about these giants of the past. And if you want to keep exploring the mysteries of life that once walked our planet, don't forget to subscribe and turn on notifications. Your curiosity is what keeps science alive. Until next time,